Hello. You guys hear me well? Great. So I'm very happy to be here. This is my first public event after COVID. I'm literally coming out of my cave. So I'm glad to see people face to face. So we're talking today about Docker and Docker within the context of containerized CI workflows. I will try my best to do to make a known term, Docker and Docker, a little bit exciting for you today. I will do my best. Okay, let's get started. So this is the agenda that we have for today. We're going to go through a brief introduction. Then we're going to describe what is Docker and Docker, obviously. We're going to explain when are you expecting to use Docker and Docker. Then we're going to go through how to run Docker and Docker and the challenges associated with that. Then we're going to jump into a potential solution for that. And then we'll wrap it up by bringing it all together with an example and a demo. Okay, let's jump to that. So, my name is Rodney Molina. I'm a software engineer at Docker. Before Docker, I was working as one of the lead developers and co-founders of a startup called Nestybox. Nestybox created a container runtime called Sysbox. I'm going to be talking about that in a few minutes. My partner in crime for this talk is Maki. Unfortunately, he couldn't make it at the very last minute. So if there's anything wrong with the presentation, something you don't like, please feel free to blame him. Okay, so let's get started. So what is Docker and Docker? So probably for most of you, the audience, Docker and Docker term doesn't really need a lot of introduction, as it has been around for a while. But let me just cover the basics to make sure that we're on the same page. So Docker and Docker is a simple technique to allow developers to run Docker container within a Docker container. Simply that. So if you have a process on that blue box there, you send out a container, and that process is tasked with trying to do some Docker-related process or task, actually. Basically, Docker and Docker should allow you to allow that process to complete and behave in exactly the same way as the Docker engine that's living in the host. There shouldn't be any difference. If things are being done right, the Docker engine inside that blue box should behave exactly the same way as the one outside. So this is conceptually simple to understand. So why are we having this talk in the first place, right? So things are a little bit trickier when it comes down to the implementation, because none of the components at the very bottom, that container stack comprised of Docker, containerd, run C, none of those components were designed with an application like Docker in mind. They were all conceived from the context of, hey, I want to run a microservice. So Docker is one of those applications that is considered system level. System level because it does a lot of tricky things with the kernel. It requires namespaces, C groups, ARP armors, seccomp, bind mounts, a lot of stuff that a regular application wouldn't really care about. So I'm just laying the ground there for what I'm going to explain next, which is all the challenges that you have to deal with and why are those challenges. Just Docker is not any application. Okay, so use cases. When do you need Docker and Docker? Let's go through that. The most obvious use case that stands out, and I think pretty much everyone here is familiarized with, is CI tools and agents. CI tool and agent probably will need to deal with jobs that require some Docker-related tasks to be completed, right? So it's natural that you need an engine, inside that CI tool, that CI agent. So that use case is pretty obvious. What is not so obvious is if you want a local containerized environment. So what I mean by that within the context of this test environments is if you're working on a repo, for example, that has a CI workflow that is not too complex, but it's not too simple. It's something in between. If it's too simple, you don't really need to have a Docker engine inside. If it's too complex, you cannot even port that CI workflow environment to your local dev machine because it's just too convoluted. It's just too complex. If it's something in between, you can think of in a scenario where you can bring that CI engine or image, let's put it that way, an image, container image, with all the tools already inside it, so that you can run your dev workflow in your local test and dev environment without having to clutter your machine with a lot of tools that you don't really care about. So that's what I mean by local containerized environments that require nested deployments. That's what I mean by that. Okay. Another use case is sandbox Docker environments. This is the environment that would allow developers to create Docker containers that act as sandbox environments. And by that I mean, imagine this scenario is you as developer, you throw all the tools that you need for your dev environment. Docker, Kubernetes, dev tests, GUIs, pretty much anything that you need inside an image. And by doing that, now you have a lot of flexibility and portability, because now you can decouple the laptop that you're working on, the dev environment you're working on, and pretty much port it across any other device that you run into. I'm especially I'm pretty excited about this use case, because I think that's where I want to go personally as a developer. I want to have an image that comprises all the elements that I'm happy with, and they are configured exactly the way that I want to. It just doesn't make sense for me that I have to switch laptops or go to my tablet or change companies, then I have to redo everything again. That doesn't make any sense to me. So I'm really looking to have something like this in the future. So this is a sandbox Docker environment, just to wrap it up, that behaves like a virtual machine. And this is actually the main driver for the startup that I was working on before, called NestyBox. Okay, so use cases are pretty clear in my mind, at least. Let's keep on going. So how do we run Docker in Docker? Let's start with a super simple demo of the challenges that, as a user, you encounter when you try to run Docker in Docker in nested fashion. It's pretty simple. We're going to cover some of what I call deployment patterns here, but we will expand on those later on. So if there's something you don't get here, just be patient, wait for the next few slides. Okay, so at the bottom, we're going to watch all the Docker PS, we're going to watch all the containers within the system. At the top, we're going to initialize a container that has nothing but BusyBox. We'll try to run Docker there. A surprise, it's going to fail. Silly example just to show that Docker by default is not included anywhere. Any distro, any image, nowhere. You have to install it. Simple, silly example, as I said. Let's keep on going. Let's try it again. Now let's do something a little bit more intelligent. Done a Docker CLI image. Already includes something, the Docker CLI itself. When we run that, good, we have a CLI there. We do some Docker PS, just an engine instruction, it fails. Why? Because the binary is trying to connect to an engine. The point that I'm trying to explain here is something obvious for many of you, which is that Docker is comprised of two elements, a CLI and an engine. You need both of them to operate. So Docker binary right here is trying to connect to a socket, a unique socket, which is where Docker by default is listening. But obviously, in the context of a Docker CLI, there's no engine. So where can we bring an engine from? Where do we have an engine from? Okay, so this is where the Docker out of Docker pattern starts to make sense. Let me go through that in a second. The first thing we'll try to do is to run a regular container. This is not really applicable, or it doesn't really make a lot of sense for the use case that I'm going to explain. I'm just showing, the reason I'm creating that container is to showcase one of the main challenges that Docker out of Docker has. So just bear with me. Look at the bottom that we have a container that we just create. The bottom, as I said, is the system level, where the Docker engine runs at the host level. So now we're going to initialize a Docker CLI container again. But notice at this time we're passing something. We're passing the socket where the Docker engine at the host is listening on. So we're by mounting that socket from the host into the container. That sounds fishy just to start. The problem with that is that when you do a Docker PS, yeah, things works. But now you're looking at all the containers of the system. That's something that you shouldn't do, basically. If you try to remove all the containers there, surprise, this is going to work. This is going to work because you are by mounting the socket from the host, so you have access to the entire system. So that means that don't try Docker out of Docker. Personally, I wouldn't do it. Now let's go with the Docker in Docker pattern, which is what this talk is all about, right? Docker in Docker, there's a few steps that you can complete to make it a little bit more secure, like create a network that is specific for the CLI and the engine. This is not really a must-have, but you could do it. You can see the instructions are more complex now. What you just did there is create a container with a Docker DIN image. This image that is well known in Docker, many people use this, already contains a Docker engine. So you don't have to search for an engine anymore. You already have a context where this Docker engine is executed. It's executed. This is the Docker CLI, as we did before, just to compare it with the Docker out of Docker environment. Now we created an engine, and we created CLI, 2 different containers. And things are going to work now. And the most important thing, we don't have access to the engines, sorry, to the host engine, which is something that we were trying to avoid. If we're trying to remove something now, obviously it's not going to work because we don't have access to the containers that are sitting at the host level. Okay, so that's pretty much it, this demo. Simple one, as I said. Okay, so let's dive deeper into the deployment patterns that I alluded to in the previous demo. So, as I said, Docker out of Docker reuses the host level Docker engine, and Docker in Docker relies on a separate and dedicated Docker engine running within a container. So let's now go through each of them. So what are the pros of Docker out of Docker? Well, within the context of functionality, the fact that it uses the host Docker engine is convenient because it saves disk space. It expedites the build actions because you're relying on a shared place where all the images are going, and you are not relying on every single container pulling images. So it's natural to think that things are faster and more efficient. But there's a big cons there. As I said before, you have direct access to the host Docker engine. And if that's not enough, excuse me, functionally speaking, you break functionality like file system sharing. Just the fact that you live in a different mount namespace doesn't allow you, by definition, to mount things from the host, which is in a different environment, a different context. So when you try to do a Docker run -v and port some file system path, that obviously won't work. It won't work because you're not in the same environment, the same context. But as I said, the main problem with Docker out of Docker is security. It's not definitely recommended for shared public environments. Now well, actually, this is a little bit of a repetition of what we went through. So I'm going to go quickly through this. Docker out of Docker, you do a Docker PS, you have access to the entire environment, and the inner container can easily kill all the containers in the system. Okay, now, Docker in Docker. What are the pros and what are the cons? The pros is that it's easy to use because it relies on a DIN image that is already prepackaged for you and actually contains both the engine and the CLI. In the example before, we split them just to compare with Docker out of Docker. But in reality, within that DIN image, you pretty much have everything that you need. So it's pretty easy to use. Another good thing is that now you finally have inner and outer context from the Docker standpoint. You have separate engines working independently. It addresses some of the Docker out of Docker security concerns, so that's also a pros. Now, what is the big challenge with Docker in Docker? That it requires insecure privileged containers, which is a no-go for many organizations. I wouldn't suggest it. I wouldn't recommend it either. So yeah, it's definitely not a feasible solution. This is, again, a little bit of repetition of what we did before in the demo. We created a network that is not really a must-have. We started Docker in Docker container. We created the CLI container, and we sec into it. And then we realized that we don't have access to the host containers, which is good. Now, the main challenge that Docker in Docker has is the fact that you're relying on privileged containers. The problem with privileged containers, to summarize it, is that the root user in the container is exactly the same root user on the host. If that's not enough, all the capabilities, all the kernel capabilities are assigned to the processes that run with the DIN container. So you can think of if a process were to escape that GL environment where the DIN container runs, that process would find itself with all the capabilities, exactly the same rights that a root user has in the system. So you can pretty much do anything. So that's why it's definitely a no-go for many organizations. Now, even if you don't escape, even if you don't hack the system to escape and go to the host, even within the container, you already have direct access to the host devices. So you can mount stuff from your root hard drive. You can mount it into the container. You have read-write access to those files. So yeah, and just to top it up, you also have read-write access to the procfs and sysfs system. So you can literally write to the kernel and read from the kernel. So I have a little bit of a screencast here, showcase that. I'll go briefly through that. Oh, it's not starting. Here. So I initialize a privileged container, Ubuntu. Looking at the proc file system, I'm asking for what is the UID mappings. It means what is the UID that the process of this container is executing with. As you can see, the first column is a 0, the second one is a column, it's a 0 too. What it means is that the process is running with UID 0 in the container, which maps to a UID 0 on the host kernel, on the host system. So that's what I mean by root user in the container is exactly the same root user on the host. If you look at, oh, sorry for that. Now we're looking at the capabilities. So we can see there the process is running with all the possible capabilities in the system. Sorry for the, there you go, all those FFFs that you see there. And finally, as I said, because you have read-write access to the kernel through the procfs and sysfs, just by writing 2 bytes into those files in procfs, you're literally restarting the entire system. Just one command, you're restarting everything. So that shows how insecure the solution is. Okay, enough. So let's talk about potential solutions. How can we deal with Docker in a more secure fashion? How do we do it? So sysbox is one possible solution. Let's go through what sysbox is. So sysbox is a new container runtime. It's a new runC. It operates below Docker and Kubernetes, even below Containerd and CRI-O. So it stays really low level. That means that the user doesn't really need to learn another tool. There's no need to operate with sysbox. Sysbox will go through the OCI spec, will listen to the requirements that comes, or the request that comes from above, and will just operate on that. User doesn't need to learn anything new. That's the important point here. So what sysbox does is that it enables more workloads than the regular containers, and it does that seamlessly and securely. How it does that? Well, it offers more isolation through the utilization of OS virtualization techniques. For example, all the containers that run within sysbox are relying on the user namespace. All the processes within a container are assigning an ID space that is unique to that environment. So that is important. And as I said, functionally speaking, sysbox allows you to run privileged workloads, no containers, privileged workloads. So that's the reason that things like Docker or Kubernetes can run within sysbox. So, and as I said before, it fully integrates with Docker and Kubernetes. So you can run it as another runtime, like runC, like Kata containers, or like any other. Okay, and finally, it's open source, important. Okay, so within the context of this talk, are we talking about sysbox here? Because if you use sysbox in a Docker environment, you have certain pros and cons. Let's go through the pros first. First thing is, this pattern is conceptually simple. It matches the traditional Docker scenario that we talked about before. It offers strong isolation through Linux user namespaces, through the virtualization of procfs and sysfs. We do some syscall trapping for certain specific syscalls on the control path, like mounts. So we stay out of the data path, so that we don't hit the performance. We do some user ID shifting to make sure that the user namespaces, are not an issue when it comes down to file systems. And all the things. But when it comes down to the main pros, the most important thing is that non-privileged containers are required. You still can run the same workloads, but you're containing the things that you can do within a container. Another important point is that this works on bare metal or cloud VMs. There's no need for nested virtualization. Because someone could say, why don't you do Docker in Docker with micro VMs, for example? That's a valid solution too, but you gotta be willing to pay for that. And not only that, not even all cloud vendors offer that option. And actually, sometimes you don't really need to go all the way into the security fashion. Sometimes you want something in the middle. one thing that Sysbox offers in comparison with micro VMs is that it's pretty easy to use. Just Docker run, that's it. You don't need to create images. There's a lot of complexity going on with micro VMs, in my opinion. What is the cons? The main one is it requires relatively modern Linux kernels, and it currently supports a limited number of Linux distros. Okay, so let's bring it all together. We talked about what Docker in Docker is. We talked about the use cases. We covered how do you run Docker in Docker. And we saw the challenges associated with that. We mentioned a possible solution for that. And now let's see how we bring all the pieces together with a demo and an example. Okay, so the first thing you can do to connect all those components that we talked about is create an AMI, a VM image that includes all the components that I'm talking about. That's what we have done at Docker. We created what we call DIN AMI that pretty much satisfy all the components requirements in terms of distro, in terms of kernel, all the things that are must-have for the components that are living inside. We already are meeting that with that image. That image is already ready for you to use anywhere. Of course, it includes Docker Engine, the CLI, the main Docker plugins like BuildX, and so on. And of course, also install Sysbox, it pre-configures, so everything is ready for you to use. Till this point, we've talked about Docker in Docker, but we really haven't touched much, we haven't said much about CI. You might be wondering, what is the CI part here? So one of the things that I'm personally vouching for is that what this model, what this DIN AMI with all the components could offer you is a way to reduce the cost of your CI environments. Because what we are proposing is, instead of relying on the current paradigm, which is if you need a runner, you need a VM, you could somehow do something different. You could say, I'm going to dedicate one VM for n numbers of runners. So before you jump out of my throat, this is not something that I recommend for everyone. This is not for hard multi-tenancy environments. I'm vouching more for a soft multi-tenant environment where an enterprise has a few teams, and those teams within the organization are pointing to a bunch of repos, and somehow you want to reduce the cost of your infrastructure. You can, instead of renting 20 VMs, you can maybe just go for 10 and reduce the cost somehow. Some of those VMs obviously will need to be a little bit larger, but it's still on the price scheme, you're still going to save money there. So that's, that's the use case that I'm specifically touching upon. Okay, so let's go forward. The example that I have in mind that explains all that we just described is GitHub Actions containerized runners. So currently, self-hosted runners work best at host level. And what I mean by that is that Dockerized runners do not support CI pipelines with Docker-related steps. Notice that I'm talking about Dockerized and not Kubernetes environments or runners, right? Because in the Kubernetes world, there are some fixes over the last few months to basically spawn this Docker container somewhere else as a pod. And they are sort of bypassing or workarounding some of the complexities that Dockerized runners have. Still, actually, thinking that, actually that's not Docker in Docker anymore. That would be probably Docker in Kubernetes, think. That would be probably a different talk. But the important thing to keep in mind is that both in Kubernetes and in Docker environments, you're still going to need privileged containers or the Docker out of Docker approach to run the engine. There's no way out of that. You're still going to need that. So the above points, the challenges that I just highlighted above, what it tells you is that we have a problem in terms of cost because we're still dedicating a VM for every single runner. And that's not the most efficient way to maximize your compute resources. That's the whole point. Okay, so this is how the solution looks like. You start from the bottom. What you have is the Docker DIN AMI that we talked about. You have the virtual machine. You have the container stack, that gray layer that you see there, with Docker, Containerd, and Sysbox. This is not run C. Now we have Sysbox. and Sysbox will instantiate those runners. And those runners will talk to repos. You know, in this pattern that I just highlighted in this slide, each runner is talking to an individual repo. But that's just an example. It doesn't have to be like that, right? You could have another environment in which, for example, you have 3 runners and you're pointing to the same GitHub repo and you're doing load balancing for jobs there. Another use case that I have in mind could be you could have 2 runners and you could have room for a third one, for example. The third one could be a debugging CI runner. Yeah, who doesn't love to debug CI issues? So instead of going to a different VM to debug that problem, you stay in the same VM. You just instantiate a runner right there. And you avoid impacting your peers. The other runners will keep on working. You just put a label when you create that runner, say that runner is going to call label X. And when you create your dev workflow, you say use that label. Your job will go straight away to that and will leave your CI environment untouched. So from a debugging standpoint, it makes sense too. Okay, and that's pretty much, let's go through a demo now to showcase what I just described. Let's see. Okay, so this is a Linux VM, my dev environment. Basically, I rely on a Linux VM for most of my stuff. This is a relatively recent kernel. There's no containers, as you can see. And what I'm going to show you now is a repo. I hope that you can see that well. It's pretty readable. This repo we just created from a fork. Actually, it's not this one. Wait a second. This one. This repo is a clone of an existing project that is pretty successful, that does GitHub Actions runners. What we did is we cloned this project, and we specialized it for Sysbox. And what I mean by that is, if you git clone this repo, what you're going to get is an option to create an image that already contains the GitHub Action runner with all the steps that you need to set it up. Everything is automated for you. And the advantage that this specific repo has is that it's for Sysbox specifically. Okay. Let's keep on going. Okay, so what we're going to do now is to git clone that repo. Because, as I said, that repo has a way to build the Docker runner, the GitHub runner image, and also has a shell wrapper that I'm going to show you in a second. What that shell wrapper does is simply wraps the Docker instruction that you will need to create the runner. I'm going to show you in a second, right here. So what that repo is bringing is the image. It also allows you to just have a silly wrapper on top to simplify the creation of the GitHub runner from your dev environment, from your virtual machine. So let's go ahead and run that wrapper. Now, there's one thing that you're going to need. Now we're back into another repo. This is not the one that we cloned. This is the repo that is going to have our dev things, our CI workflows. Everything is going to be in this repo, okay? And in order for me to create a repo, in order for me to create a runner from my virtual machine, I need some tokens, something that allows me to authenticate to GitHub. So how do I do that? How GitHub does that? GitHub allows you to create tokens for that, obviously. Let's go through that. Settings. Click on Linux, and there you go. This is the token that we need this right here. Notice that all the other steps that GitHub publishes for the users to follow, none of that is needed. All that is already automated within the runner image that we pre-built before, so you can skip all that. Actually, there's even a way for you to avoid needing to generate the token. If you use the personal access token, then you could do pretty much anything as long as you have the rights within that repo. So technically, you don't even need to do this. But let's just go with this example. You get this token, which is all you need. And now you invoke this silly wrapper, which is nothing but a Docker command. Notice that what we pass in here is the name of the runner. We call it GitHub Action Runner 1. We pass the organization, which is the one that I was working at before in SDBox, the repo, which is Sysbox Packager, and then we pass the token. That's pretty much everything we need to generate the runner. The runner is created. Let's look at the logs associated with that runner. See that GitHub Actions is coming up. We already authenticated. And now we're listening to the jobs that are going to be coming from GitHub. Let's take a look at GitHub side, and let's make sure that the runner is already existing there. There you go. It's already ready. And now let's try to work a workflow. This is the workflow that I created that simply has a Docker job. Basically, you're building an image and you're pushing an image, something that currently today, as I said before, is a problem in Dockerized environments. Now let's try to run this workflow. Okay, I made some changes in that dev branch where I have my dev workflow. Okay, so we'll see that right away here we're going to get a job coming from GitHub. There you go, running job. This is the usual stuff. Nothing here that you haven't seen before. If you have worked with GitHub Actions, the workflow is going to start executing. It's going to take a few seconds. It's not a, I could have picked a simpler task. This one takes a few seconds. So we're building the image right there, and we're going to be pushing in a second. There we go. Post checkout. Completed. Okay, so just to make sure that we're on the same page, and then I'm not tricking you. I'm going to show you, in fact, that's exactly what happened. We're going to exec to the runner. I'm going to show that there's no running containers anymore. I could have shown you when it was running, but I didn't. Miss that. And this is the image. This is the image that we were trying to build in the first place. So this actually happened. I'm not lying to you. Okay, so this all makes sense. I mean, we created a runner within a dev environment. Now, what is a different thing that I'm vouching here for? Well, you could create more than one runner. That's the whole point, right? So let's try to do that. Let's try to create more than one runner. We're going to leave that runner right there. And then we're going to call the exactly same script that we ran before with a for loop. We're going to copy and paste the token that we used before. And all of a sudden, in literally 2 or 3 seconds, you're going to have 4 runners running in your machine. It's that simple. And as I said, they are isolated in the sense that they all have their Docker engine. Processes within that gel environments are well more contained than if you had a privileged container, obviously. And still, you're not paying for the cost of having a virtualized environment. These are the runners. You have 4 runners right there, and they are all now ready to execute jobs in parallel. So yeah, that's pretty much it. That's what I had in mind for today. So yeah, is there any questions that we might have? We still have some time. Just, well, while you think about it, let me just say that, yeah, go ahead, please. Can you please come to the mic? Sorry, I didn't say that.
Okay. Could this be adapted for self-hosted GitLab, the shell script?
If this could be helping you.
So GitHub or GitLab has its own version of runners. Can that be adapted to Sysbox for that as well?
Yeah, absolutely. I don't see why not. Yeah, actually, we already have Sysbox. My understanding is that a lot of people are using Sysbox in GitLab environments. So yeah, you could definitely have a GitLab runner being powered by Sysbox. Okay. That was actually our first use case before GitHub runners came out. So yeah, absolutely.
All right, thank you.
Thank you.
When you have all these layers nested together, is there a kind of a lag maybe for like file access on the host machine type thing that's introduced that causes a noticeable difference?
You know, when it comes down to I/O and performance in general, I would say this is as efficient as it can be. You're running in the same OS. You're reusing the kernel. The alternative to that is to have a virtual machine. Hypervisor have a cost in performance. So when it comes down to throughput, probably it's definitely going to be more efficient than if you were to have virtual machines in a nested fashion. Is that what you're trying to get at?
Yeah, sort of. I think so. The SysBox doesn't really introduce that much of additional overhead in terms of that. Okay.
No, I'm sorry. I got your question now. No, SysBox is just a container solution. It's just another run C. So everything is running within the same kernel. You're not adding any layers. You're just adding more interfaces, some network interfaces, and some namespaces on top of that. So no. So if there's no more questions, or if you have more questions, please come join us at the Innovation Lounge. I'm going to be hanging around answering all the questions that you might have. And yeah, thank you for being here.